electricity in its applied sense refers to electrical circuits. It's the only way electricity is going to be produced, that move of electrons. So in order to do that, we need this voltage source. For an example, a generator, a battery, a power plant. It's all about that differential we talked about before. So the components of these different circuits can be the switch that regulates the battery, the resistors, so it would be like a light that consumes that, motors. All these have different applications within the electrical circuit. So for us to understand the relationships and how these come together, what we're going to do is we're going to use Ohm's law. So you have three variables that are explained with this: voltage, current, and resistance. So what we're going to do is, moving forward, I'm going to show you a circuit diagram, and we're going to use this for all our calculations. So that was kind of in terms of providing you the theory, and we're going to transition into the applied sense of how to calculate these different variables based on the information that I'm going to provide you, which is always going to be 2, because algebraically you're not going to be able to solve it if I don't provide that to you. We're not getting there. So Dr. Harris, which is the electrical engineer, a colleague of mine, he uses something of this figure to easily determine what your variables are. So if you want I, you can cover up and it's V over R, or preferably I like to do the algebra, whatever works for you. However, this is what the complete sense is. So we're going to have our voltage right there. We're always going to have our plus and minus. We're going to always have a direction of current, just so that's out there. This is always going to be our resistors, and it's always going to be complete. That's how you're going to have those three variables, and that's how they're going to be applied within a circuit diagram.